Hi, so I want to just talk a little bit about the results of our experiment with the UV so everyone can see the class results, and we'll talk a little bit more about it next week. These are the results collected with the MOXI little mini flow cytometer with the help of George Hung from Gemini Bio. Here's our results. So not everybody was able to get results with the MOXI, but those who did had a nice trend resulting from our data. As you know, the L929 cells were exposed to varying degrees or varying amounts of time to UV prior to being collected and stained with propydium iodide and analyzed in the MOXI system. The 10 seconds of exposure still had 96% viability. At 30 seconds of exposure to UV, there was slightly less at 93% viable cells. And you can find that information right in the printout from the MOXI. And what you want to realize, what you're looking at here, this is the diameter of the cells along this x-axis, and this is the brightness with propydium iodide. Remember, propydium iodide is only taken up by cells that are no longer functioning. Their cell membrane becomes very leaky and the propydium iodide is taken up. Therefore, propydium iodide brightness means the cell is dead. So over here, we see cells that are not bright with propydium iodide because they're low on the y-axis, and these cells vary in size from about 12 to larger. So these are probably cells clumped together over here, perhaps 2 cells clumped together. Okay, so these cells are alive. These cells up here are dead. And these are too small, probably to B cells. Okay, perhaps right here, we still have some cells that are in the process of dying, but they haven't taken up propydium iodide yet. But these are getting too small to be our eukaryotic cells. So these are pieces of cells, debris, propydium iodide clustered together and whatnot. Okay, so this is what we're looking at right here. So 10 seconds, still 96% viable, 30 seconds, 93% viable. As the time increased, we were able to get readings on 2, 4, and 5 minutes. Above 5 minutes, we could not get a reading, which in my interpretation, the cells had completely fallen apart and we were only seeing pieces of cells, so we did not find viable cells. At 2 minutes, there was 86% viability, so the trend is going downward. At 4 minutes, we're down to 72% viability. And at 5 minutes, we're at 67%, or 66.7% viable. So the trend of our experiment actually is working out very nicely. The one problem is the collection of our cells. So being that it was the first time the class was working with this, we probably had quite a few places that errors could have occurred, but the trend overall looks good. So our experiment worked pretty well. I'm pretty happy since it was our first attempt at doing this particular protocol and the first time using the MOXI. So congratulations, everybody. So just looking at the trend overall, the summary, you can see here's our summary of viable cells, right? And we could not get anything out after our 5 minutes. We observed small pellets for the samples that were exposed to 9 minutes, and you could see there was turbidity. It was cloudy, so probably all the cells were dead, and the cells had been rupturing and releasing their contents. There was this good trend of decreased viability with increasing UV, right? And that is really good. And we lost some samples, right? There was probably some error with the experimentation itself, with the students trying to collect the pellet and just various issues that came along. So we know that there were some problems there, and we were experiencing cell lysis, which was not allowing for a really nice solid pellet like we had seen the day before when we were collecting our cells from being brought out of freezing and plating them in the T25 flasks. We know that the pellet should have formed, but we weren't seeing a very good one in some of the samples. And I believe that meant that there was a lot of cells that were breaking apart. So no longer did you have intact cells to pellet, but you had pieces and parts of cells, which are of course a lot smaller and not pelleting very well. That's the summary of the experiment. We can talk a little bit more about it in class. See you later.